I have to break my video up into parts here, so that's what I'm doing. All right, operating system has layers, and that makes for portability. So the operating system then could be moved to another computer, and if a different type of hardware is developed later on, the operating system would be able to communicate with that new hardware by using new drivers. And so as the operating system changes, that has to be updated. But at least the application software wouldn't have to be changed. That's why today you can still run programs written for the original IBM PC. If you've ever seen an IBM PC, I'll show you a picture of one here. It's this guy here. That was the IBM PC. And it had the first operating system that we're going to be discussing today, the disk operating system. You can still run software from that old IBM PC from 1984, yeah, way back there. You can still run that old software on the latest operating systems. Running Windows 7 or whatever, you can still run those old versions of the operating system. And that's because what the operating system does is it provides this layer of compatibility here. Now, old programs that were written for way back then, they were not necessarily designed to be isolated from the hardware. In fact, a lot of those old programs communicated directly with the hardware because they didn't really have this concept working in those days. But today, when the programs run, they think that they're communicating with the hardware because the operating system provides facilities that isolate the programs from the hardware. That's called virtualization, where you make a program think that it's running on hardware when it's really running completely in a software environment. Another things that operating systems do for us, they have several characteristics, but there are three main things that they do for us. One thing is modern operating systems allow us to multitask. Multitasking means that we can run more than one program at the same time. It's not always been the way. Early PCs could only run one program at one time. In fact, the original IBM PC could only run one program at a time. So this is not a feature that's always been available in operating systems, but it is today. The first Microsoft family of operating systems that ran multiple programs at the same time was Windows version 3. And what it did was what was called cooperative multitasking. Cooperative multitasking is where one program runs for a while and then it switches over to another program and it runs for a while. But each program does this with the cooperation of the other programs. So what has to happen is the first program has to pause or stop for a little while, just stop what it's doing and take a pause or take a break, if you will. And then that passes the resources of the computer over to the next program. So let's say we name our programs here, Fred, Harry, and Joe. Fred will run for a while, it will pause, and then let Harry run for a while. Only one can really run it at a given time. Harry runs for a while, and then Joe runs for. Harry pauses, and then Joe starts to run, and then Joe pauses. And so what happens is, as long as they keep doing that, these programs can keep cycling around, and make it appear that they're running at the same time if they do it quick enough. To us, it appears that they're running at the same time. This works fine as long as all those programs cooperate. If, though, one of the programs doesn't cooperate by pausing, if it just hogs the computer's resources and doesn't give it up, it doesn't pause, then the other programs won't get a chance to run. It'd be kind of like somebody, you know, at the drinking fountain, and he keeps drinking and doesn't stop and doesn't let anybody else in line get a drink. All right, or whatever's, there's a queue, in other words, a line of programs that want to use the resources of the computer. So the early versions of Windows did this, and also some of the early versions of the Mac operating system would do this as well. So sometimes if a program got hung up, the whole operating system would just stop, because that one program would, you know, say the program got stuck in an infinite loop where it was just doing something over and over and over again, and it couldn't get out of it, or it crashed. Then the whole operating system could come down. So the early Mac, early Apple operating systems, and the early Microsoft operating systems had that problem. So what they did later was they went to preemptive multitasking. That's where the operating system forces the programs to stop. It's called time slicing. The program has no choice. It simply halts. It just simply quits. It's almost as if the computer suddenly stopped processing for that program. And the program itself doesn't know any different. Each program has its own piece of memory, and it thinks that it's the only program on the computer as far as it knows. But what it really has is a fraction of the resources available to it in terms of the amount of memory that's available and in terms of the amount of processing time. And preemptive multitasking solves the problem of one program hogging all the resources of the computer and causing it to lock up. If one of the programs in a preemptive multitasking system crashes or something malfunctions, the other programs can continue running. Generally, that doesn't necessarily bring down the operating system. Now, there's still things that can go wrong, and sometimes programs still manage to crash the operating system even so, because it's not perfect, and the isolation between different programs isn't completely modular always, meaning that they don't always live completely in their own world. Some programs depend on other programs. In fact, you can see an example of that if you go to your computer and you can actually look at the processes running by doing a Control-Alt-Delete. Now, I have Windows running on this computer right now, Windows XP, and there are actually a whole bunch of tasks running inside the machine here. And this is running in a virtual machine right now called VirtualBox. You can get VirtualBox for Windows also, and you can run different operating systems inside of another operating system. What's nice about that is you can switch between different operating systems and try things out. You can even have it crash, and it won't cause any problem for the computer as a whole. But if you were to look under the hood, as it were, under the operating system, you'd actually find there's a lot of different programs running simultaneously. And you have a control panel for Windows, and in the control panel we'll be accessing a lot of the features of Windows, and making settings and changes and so forth. We'll be using this quite often. You get to that by clicking on the Start panel. Here you go, just Start and Control Panel in Windows XP. Windows Vista and Windows 7 are very similar. They also have control panels, but they're a little different style. Let's see here. Where was I? Get back to my slideshow there. So that's multitasking. It switches between one task and another rapidly to make it appear that it's running simultaneously. Another thing that's sort of like multitasking and often gets confused with it is threading. Threading is where you take a program or a job and you break it up into parts and you have more than one processor working together. Today we have a lot of PCs which are dual, triple, or quad core, meaning they have 2, 3, or 4, or even more processors. And by doing that, you can break up a job into parts and have one processor working on one part of the program and another processor working on another part of the program, and those are called threads. So you can make a task perform more quickly that way if you can break up a job. Not every job is amenable to this. Not every job fits this. You know, some jobs have to be done in a certain order, and you can't do one thing before another, and so forth. But certain kinds of jobs work very well with multiple processors. Another thing you can do is if you have multiple processors, you can have one program run on one processor and another program run on another processor. The operating system provides a user interface. Oops, let's go back here. User interface. Two kinds of user interfaces are available in most operating systems. This is true of the Apple family of operating systems. This is true of Windows, and it's true of Linux also. And that is a text line interface is available. A lot of people never use this. But we as technicians will find that this is quite useful and very indispensable for certain things. And this was the original kind of interface that the early versions of the Windows, or actually Microsoft operating systems, the disk operating systems had only. They didn't have anything but this. The other thing you would be able to have on most operating systems today is a graphical user interface. The graphical user interface makes it easier for the average user to interact. The old text-based interface was a lot more intimidating to people than a graphical user interface, and a lot of people take this for granted today. But it wasn't that long ago when we didn't have graphical user interfaces. And we'll really focus next week on the graphical user interface, and we'll see how the graphical user interface does much the same tasks as we can do with the text interface. It just hides it from us. For example, today we're going to look at some of the commands that you can run in the text interface, which we call the command prompt or the DOS prompt. And we'll see that there are commands that do the same things that we take for granted in the graphical user interface, like the ability to create folders or directories, or to move files or copy files, or to look at the contents of a folder or directory. The other thing that the operating system provides for us is a file structure. A file structure is an organization for all of the different items stored in our storage system. And that would include all of our programs, all of our data files, any kind of data of any kind that we store in the storage system needs to be organized in some way. And that's the job of the file system. And the model that is used in modern operating systems is the idea of folders, like a file cabinet. You know, you have a manila folder, you put stuff in it, and you put it in the file cabinet. Except that unlike a file cabinet, a computerized file system allows you to put folders within folders. I'm going to pause for a second here.